We are live. Matt Johnson, do you hear me? Taylor
Hey,
Smith.
hey. Sneak peek there. Taylor will be joining us. You might as well stay now,
right.
Taylor. Welcome, everybody. You're joining Codified Security episode 22 on March the 14th. I know, 22. We've even got a real cadence of monthly now and everything. It's very exciting.
It's worth mentioning that, actually. Yeah. It's mentioning the cadence
sure.
now. If we did, some people who are watching, we're going to be doing the second Tuesday in every month? That's our goal, right?
Tuesday every month. And even if we are not technically here for a live stream, you will still be getting some content. That is our promise to you. So we will be regular. You will be able to set some form of pocket watch buyers or something like that. So welcome, episode 22. You're joining me from Manchester, as usual. Steve, whereabouts are you in the world this week?
I'm currently in Toronto, Ontario, Canada, as will be reflected by the beer I will have.
Ooh, very exciting. And Taylor, what about you?
I'm in California, Bay Area.
And that will be why you are probably not going to be cracking a beer with us. What time is it over there?
It is a lovely 10 a.m. here.
Understandable.
A little early for
taking the responsible approach. Yeah, 100% agree. 100% agree. Oh, well, welcome one and all. Yes, absolutely. Taylor is joining us for a very exciting demo-packed episode. He's going to be walking us through a load of new features in Chekhov, showing us what they can do, how they do them, breaking out his screen share. So we're very excited. We've got some news as well. But as always, Steve, let's start with the beers. What are you drinking today?
Nothing until I do this. There we go. I have a Kensington Brewing imaginative title. It's another hazy beer. Beautiful art, but this is local Torontonian. I've never had anything from this brewery before, so 5.5%. I'm not going double IPA at 1 p.m.
That's understandable. I'm also being quite sensible, even though it is 5 p.m. I have an early morning flight tomorrow. I'm going for a 5.8%, and I am going to have to turn this light quickly off to do this. This is a Citra beer from Iron Hill Brewery in Detroit. So I was in Detroit for a couple of days recently, and it was dry January, so I wasn't drinking. So instead, I deferred the alcohol by bringing it all home in cans, and now I'm slowly working my way through it. And Citra is one of my favorite hops, so we'll see what it's like.
I like how you go through dry January, right? So you do all the healthy thing, but you still black beer.
Oh,
so God, now you're playing catch up.
Basically, yeah. And
same beer gets consumed just at a different time.
It's probably not meant to work like that. If I was doing it for charity, there might be some calls of that being cheating, but it is what it is.
Fantastic.
Anyway,
yeah, good.
Cheers, gentlemen.
Oh, cheers. I haven't even tried it.
Same. Cheers.
Dude. Cheers.
Yeah, it's fantastic. It's going to be a good episode. All right. What's first on the agenda?
Okay. Well, what I thought we would do is, after the drinks, intro Taylor. But since he's already here, Taylor, welcome back to the show. If I was good at reading through the show notes, I would know which episode you were last on, which wasn't that long ago. I think it was 19, maybe 18, something like that. But welcome back.
Thanks. Yeah, glad to be here.
For those who don't know you, explain your role within Bridge Group, Prisma Cloud, Palo Alto, wherever it is now.
I don't think we have any viewer who hasn't watched every single episode, right? So I am a senior product manager for code security, which is part of Prisma. Majority of my use cases are around the scanners we have. So we have today IC scanning, secret scanning, and SCA. And I cover the actual scanner side of that. That's my product territory.
Very
So
cool.
a lot of overlap with the open source community and Chekhov as we have there.
So if someone's angry that a feature hasn't made it into Chekhov, that's your fault.
Well, you can blame me. My Twitter's showing.
Wonderful. So yeah, Taylor's been with us a few times. Those of you that join us regularly will know. To kind of give us like a sneak peek of things that are being developed or have recently just been released. And as it turns out, this month there is plenty to go around. So why don't you give us introduce demo one, Taylor? What is it you want to show us?
Yeah, so let's talk about secrets for a second. So people are probably familiar with secret scanning. I'll go over for a quick intro on them. Essentially, this is if you're looking at your repository or you're looking at your local code and you notice, hey, I've got to make this connection to a database or to GitHub to do automatically, then I might have secrets to make that really easy, to make, let's say, AWS access tokens to deploy something very easily and put it in my provider box. It simplifies things for development because the moment it shows up in your repo, it becomes exposed. And you might say, oh, I have a private repo, it's all good. Well, we saw from Toyota and from others like Samsung and some other NVIDIA, that's not good enough. You have people who, with all the best intentions in the world, might copy code secret, and then that gets uploaded to a public repo. It's basically not good to expose secrets. So we have a secret scanner, and it's built into Chekhov. We've built these that only come once you have the platform integration. But let's talk a little bit about what happens in secrets. How do you prioritize? And then kind of the opposite thing. What if I have secrets that I used to have and now they're no longer there? How do I handle those? So just looking at the first demo, what we do, so very simple. Any Chekhov scan that you do by default will have a section for secrets. You can see I ran a very simple just Chekhov-D, and I've got this experimental flag for now. It's going to be to the default behavior soon enough. Then I've changed the framework to focus just on secrets. But it's identified all of these secrets: AWS access keys, Databricks authentication token, GitHub token, GitLab token. So I've got all of these secrets. How do I pick and choose which one to start with? So we've added this feature to validate the token. So you can see here, I've got a valid token. Don't worry, I've revoked it since. But I've got a Terraform Cloud API key. So it's telling me it has been bid. So we basically reach out to a public API with your token over encrypted channels, of course. And say if we get a certain response back, we know it's a valid token. So you can prioritize that over, let's say, this Circle CI token that's not valid. We sent it over to the API. We got some sort of response back, either 400 or sometimes it's in the response body. We're going, a vast majority of when we do them will have this validation. So you can pick and choose what are the ones to go after first. So
Very cool.
That's validating secrets. And then let's jump over into history scanning. So the idea of history scanning is if you have a secret and then you realize, oh no, I've put it in my repo, that's a bad thing, and you delete it, that doesn't mean it's gone. We all know there's an immutable history of Git, and there's ways to force change, force delete things out of history, but it's quite messy. So there's a good chance that a bad actor could do a deep clone of your repo and then run a history scan and still get access to that token. So I've got an example here where I've got an IBM Cloud API, and you can see I've added it in this commit, and then I removed it in a later commit. And so I'm able to, with this scan secrets history, go back through history and see if there are any secrets that were removed. So they're a normal Git scan of your latest commit would not pick it up. But running this history scan would dig through history and actually in your history of that afterwards, so you know where it is and you can revoke it.
Very, very cool. Yeah, just looking back, we released secret scanning in July of 2021 into mainline Chekhov. So, you know, awesome to see we're kind of keeping on top of, well, that's all well and good, but if you have 1,000 results, which secrets do you really need to care about? And what about the ones that don't look like they're in the repo when you browse it on github.com, but actually are deep in history, because attackers are doing this these days. So yeah, very, very cool.
Yeah.
So does it combine the two? So does it do verified secrets within your history?
Yeah, so you're a step ahead. So exactly. Once you can think, we have a customer with over 1,000 repos when they did their initial scan. Over 1,000 secrets findings when they did their initial scan. That's already a lot.
Mm-hmm.
If they were, you can imagine it'd be multiples of that. So we are planning on in the future combining the two. So you will actually be able to validate history findings, and that way you can prioritize over your history findings as well as your recent commits. But you can imagine how much more important it is to have that validation and prioritization after
cool.
you do.
Yeah, love that.
It's also a huge problem, because as somebody who has accidentally checked in secrets into my own repos several times, not innocent here. Your reaction is to go, oh gosh, and then you take it out of your Git because it's not there anymore, but it is, because it's Git. It's sitting in the history. It's there forever, and you may not have deactivated it, thinking you got away with it.
Right.
And it's like,
deleted it, so it's all good. Yeah.
And you can purge your history, but that kind of goes against Git. Like, you shouldn't really. There's some good how-tos online that say if you do this secret and you remove it, you still have to wipe it out of your history. There's no way of, and it's like seems like an anti-pattern to do that.
We're talking forced squash pushes and things like that there, which are all well and good until developer number 2 pushes their source of truth. And yeah, unless you're working on a one-person repo, and even then, the first time you've pushed it, if it's public, like you look at like some of the third-party Git history websites, they've taken a cache of that commit, whether or not you force push squash it on github.com. So someone's going to find that secret. And just to add to Steve's point, I've done it myself, not necessarily just to my own private repos either. So not, ashamed, but not ashamed to admit it, because we all do it, right? We've all been there. Like, you forget that something's there, you're working on hacking a POC, things like that. So yeah, super useful.
This has become the secrets committing confessional. If you're watching and you want to just confess to us now, it's okay to do that in the comments now or below the
This
video.
is a safe space. It's
a safe space.
Yeah. Safe room. If you too have accidentally committed live secrets into a repo, welcome. You are no stranger here.
My personal story is I thought I was being so good. I had my nice git ignorer and I forgot the config file. So I had done my proper git ignore of my variable file, and then I forgot the config file that automatically added my secret for one of the tools I used. Exposed.
Classic.
Yeah.
Awesome. Okay, so
very cool.
We have more demos coming. What's next on the agenda master?
Next on the agenda is news. We're gonna save Taylor's voice for just a split second and cover some other topics before forcing him back to work with another awesome demo. So what is up on the news this week? I have a couple of bits. Docker Hub is finally, after threatening for what feels like years, sunsetting their free team organizations. And again, talking of I'm guilty, I still have one because it carried on working, and I only use it for like 2 pulls a week or whatever for when I'm hacking around with stuff. So I have a megahertz like organization in Docker Hub. So that's going to force me to go and find a new home, I guess. What do we think about this? Is this like, Bridge Crew, now Prisma Cloud, product-led growth, letting people kind of get value from your tools is a huge part of, a developer finding it easy to grab the tools they need and get working with them. Are they almost pushing their existing user base away with this, or is it a requirement because of the amount, I'm sure, running that kind of infrastructure was costing them in the first place?
Yeah, I don't think they're pushing away, but yeah, these are I don't know, financially taxing times, let's say, and maybe it's a decision solely based on that.
Yeah,
do you have a hot take, Taylor?
Not a hard take. I think Docker has had such a trying history. I mean, I think we all know that Docker was almost acquired for multiple billions of dollars by Microsoft, and then their watch the valuation get slashed down to the sub 100 million. And so I think they're just struggling to find a monetization model that will actually work.
Yep. Sounds fair. So I don't know. I don't think they want to push people away, but sometimes it's like you can't hemorrhage money at the convenience.
Free software is hard. Let's leave it at that. In other news, Steve, did you have some API OWASP hot takes?
It's sort of a hot take. It's a hot take on a hot take. So that's even better, right?
Some inception going on there for sure.
There is. So there's the OWASP API Security Top 10. You might know, heard of there's a lot of OWASP Top 10s. We've just inherited the CI/CD Security Risks Top 10, which is pretty cool. So you go check that out. I'll put the link in the chat. But not updated in quite some time is the API Risks Top 10. And some people might argue, like, do we need yet another Top 10? I don't know. But the important thing is there's a 2023 workshopping new categories ready for the upcoming release of this one. All fine and good. Nothing wrong with any of that. Now, OWASP, let's say Pundit and general talkie person, We Hack Purple, Tanya Janka released a video, which I'll see if I can show just a teeny tiny bit because you can see the words on it, right? Apologies to Tanya for the bad pause there. But he's talking about some are trying to. Now, I don't know if Taylor could read that, but she was saying vendors are trying to influence the 2023, saying, well, if my scanner doesn't pick this up, then it shouldn't be on the list. So they're trying to. It's her hot take that vendor involvement is kind of messing up the process of creating a proper API Security Top 10. And I thought, ooh, boy, I don't know that I would have gone full on well, I wouldn't have gone on TikTok. Goodness, I mean, come on, that's the worst platform ever. But I just said it because right below this, you have OWASP old boy Jeff Williams basically ripping into this whole commentary, and it just goes on and on and on. So I am interested what you think about that. Vendors trying to influence an OWASP top 10 of any kind. Ooh.
This wouldn't be the first time the tail has tried to wag the dog, right? So
I find it, well, see, Jeff Williams is actually arguing for vendor influence, I think. And like if you read through a lot of his comments, because vendors do he provides a lot of good feedback into various other top 10s. He's like heavily involved. So I think he's trying to go slow down here. Okay. A lot of the vendors, Cider were heavy contributors to the CI/CD OWASP top 10. They're almost like the biggest contributor. Yeah. So that's heavily vendor influence, but it's not wrong.
I think there's probably a difference between being a vendor that is a place where they have the data of what they're seeing in the field versus the salespeople wanting to use it to make it easier for their product to tick the boxes. Yeah.
I think there are
devil's advocate for either side.
Yeah, I think there are enough researchers with integrity to realize the difference. And I know for us, and I'm maybe heavily biased, but I know our researchers, when they contribute, vulnerability as an example during their research or a finding, it's really they put it out there. We've had examples of findings that we couldn't at first launch find and like fix and repair. And I think there are enough researchers out there contributing, and they need to have paychecks, so they might be coming from a company. It's an interesting concept to shut them out completely.
Yeah. Talking of contributions to OWASP top 10s and also excellent security researchers, shout out to our new CIDR colleagues, who we are hopeful we will have on the show in the coming episodes. And yeah, they've been talking to us about the work they've been doing on the OWASP CI/CD top 10, and also some of the things we can't share, which is like current areas of research, which are super interesting.
Cool. Okay, so that was my hot take on a hot take and my news.
I like it. We don't get particularly what's the word I'm looking for? We don't talk about hot button topics particularly often on the Codified Security Office Hours. So maybe we should do that more.
It's a new era.
It is indeed. Another small bit of news from Chekhov. It wouldn't be right if we didn't talk about at least one commit in Chekhov on this show. We have our 300th AWS traditional Chekhov Python Terraform check. So CKV1_AWS 300. It is about making sure that you automatically, making sure you automatically enable the deletion of failed uploaded S3 objects. So more of a cost-saving one than a security one. But when you have thousands and thousands of buckets with petabytes and petabytes of files, it's probably not a bad shout to just take that tick box. So yeah, thank you to James for pointing that out to us before we went live today. Number 300 of many thousands of checks across the board, but cool.
I'm saving my CKV contribution to when we have 999. The moment we do, I'm hitting send. It's in draft right now if you go.
You've automatically scripted the sed to change it to 1000 and commit.
Exactly.
This is now having a negative impact on community contribution.
Yes, I'm sure we're preventing people from contributing because we're 699 away from me messing with the numbers system.
If you want to make Taylor's Day, it will only cost you the time and effort to do 600 commits.
That's right.
Does anyone have any more news, gentlemen? Oh, sorry. Yes.
No, nothing.
I think we should move on with the next exciting demo.
I think we should. Do you want to introduce demo number 2, Taylor?
I do. So we have spent the last few months getting really deep into Terraform. So I think universally Chekhov is considered at least, if not the number one Terraform security tool. It's definitely top, one of the best out there, and one of the most important. And we have basically taken that and really invested in going much, much deeper into Terraform in places that no other can. And really excited about this because it's value we're adding for our customers, but it's also, we contributed to the open source. So nothing I'm showing versus the secret scanning, some of that is closed source. Nothing I'm about to show is closed source. It's all open source. You could check it out and try it out for yourself. And these issues, some of the things I'm talking about, so dynamic block support, nested modules, multi-hop variable rendering for each. And then the last one is really boss mode. I'll save that one kind of as a teaser, making a connection of the plan file and the HCL. And all of these have been issues in Chekhov. And so really glad that we're now completely checking these boxes. So without further ado, let me jump into it. So I have a very simple example first, and then I'll kind of level up into the more advanced use cases. So if you're not familiar with Terraform for each, basically this allows you to create more than one instance of some resource. So in this case, I have an AWS instance, so an EC2 instance. And instead of, I want them to be exactly identical, instead of using the same AMI, the same instance type, the only difference is I want them, one, to have a public IP address and one to have not to have a public IP address. So little things like that you want to, you basically, it's kind of like modules where you can templatize what you want and then create tons of them. And you can even nest this. So you could have a for each inside of a for each, or you could have a module for each, and then the module block calling it could also have for each. And before we would see this and we would just scan this resource and I get that this each dot value comes from this variable source. But luckily now we can actually handle that. So if I, let me just check the thing. So what I'm going to do is basically so this is an experimental flag. So Chekhov enable for each handling equals true, and that will become the default in just a couple weeks once we finish our testing. But now we're going to handle that for each, and then I'm just doing a normal dash file scan. I filtered it down to framework, but that's not necessary, and then a specific check, which is making sure you don't have a public IP address. So if I run that, we'll see that I have one instance that passed because it was false, and then I have one instance that failed because it was true. So now we can handle that situation. And then I always like to show the before and after scene. So if I were to turn this off, basically read this in isolation, have no idea. And it would just give you a false sense of security that you have no public IPs. So that is our first deep dive. So now we handle for each in resources. And then moving on to dynamic blocks. So we've also added now support for nested modules and dynamic blocks. Dynamic blocks are kind of similar to for each, where you templatize, you have a resource, but inside that resource, if you have some sort of characteristic that is repeated, so the most classic example is security group, firewall rules, you might say, okay, I want one firewall or one, but I want to have some ports open, some ports closed, some ports open to specific IP addresses. So I can create a map or a list. In this case, I've got a security rule that's a dynamic, and the values of that security rule are not known to me because it actually has to go into the value. But what's tricky about this example is I go to variables to say, okay, where is this variable fail and NSG rules? And I got to dig in here and see, where is it? Fail NSG rules. Okay, it's here. And then, okay, so it's an input variable. So now I have to head over to the TF-vars, and now I get to the actual values, this fail NSG rules. And I can see I've got port 80 open to the world. That's a big no-no. And then I've got TCP 443 open to the world. That who cares? So I've got a few different examples here. 3389 is not a good one. So I've got a few examples here of good and bad. And the old way of doing this, we'd have no idea what was defined. We'd have no way of making that multiple hop to get there. We'd have no way of handling the actual dynamics. So if I start with, so this one in Chekhov already, so I could just do a simple -d and then grab the directory in this dynamic block map. And you can see we've got this CKV where port 80 is open to the world. So that is a big no-no. And so it picks up on that. And if I wanted to see, again, that before and after, let's just turn off the dynamic modules and see what it looked like before I could make that jump. And you could see I got a false sense of security because in that original dynamic file, there's no reference to port 80. So now we're able to get really deep into jumping. We basically, the technical side of it is we're spanning our graph. So instead of just connecting node to node over a single edge, we basically skip over the edges to get to whatever the destination node is. So it's a single span across those nodes. And now we can do that out of the box for dynamic blocks, and we're coming out with that for each in a couple weeks.
That is
So a couple weeks.
awesome.
Okay, awesome. Yeah. This is really cool. I think people are going to be curious as to how common is this pattern. That's, I guess, what's going through my head.
So we looked at our own customers and the blocks we're scanning, and we found outside of the free users, who some of them are just demo or playing around, a good 50% of them are using one of these, either for each or dynamics or both. So it's actually quite common. I was pretty surprised and I guess pleasantly surprised because it was my feature that I was building out, but shocked that it hasn't come up often for other. It's a gap in terms of other scanners. Chekhov was not alone in not being able to handle this.
Interesting.
Awesome.
And yeah. And so, you know, those kind of feature flags with those environment variables you had on the demo, Taylor, they won't be necessary, right? When these features are fully tested, like you said, in a couple of weeks, they'll just be turned on by default for people running the big, wide Chekhov-D dot for a recursive directory scan.
Yeah, correct. And you can kind of get an indication of that. So the dynamics one is now out of the box. No variable is necessary. But you can always tell that it's an experimental one that's going to go away when it's Chekhov. When it's a permanent one, it's CKV underscore. So this one's going away, or this one is already default on. And then that the for each one will be the next one to be default on.
There is a internal, but not internal because it's open source anyway. But there is a developer sneak hint there. Like if you are searching through the Chekhov code base looking for in-process features, like grep for Chekhov underscore, and you will probably find the bits of code that are in development.
That's right.
Very cool. One final thing I did want to say, completely unrelated at all, but pop quiz. Like, what is TCP 3389 and why is it bad?
Ooh, RDP, right?
There we go.
Yeah. I luckily refreshed my memory looking at this. I was like, what's wrong with that one? Spent too much time in Unix.
The number of times, like in my history pre Linux, that you would see 3389 Windows servers hanging off the internet with a public IP. It's like all the things you really don't want. Anyway, I digress. Fantastic. Yeah, that is so cool. I know that, you know, coming from Bridge Crew, you know, now into Palo Alto, we have been talking about solving this problem in terms of not wanting to have the plan file to work out what the final resultant variables were, you know, within the native Chekhov scanner for ages. So the amount of work that's gone into this, Taylor, by, you know, your product team and the internal devs is not to kind of go without fanfare. So yeah, really appreciate that. That's super cool.
Yeah, 100% agree. You know, I often get that question of why not just scan the plan file? It's all there, and all the for each is fully variabled out and everything. But connecting the connective tissue to the actual code where I fix the problem is a little harder. So we're just making that much easier to find the true source of the problem, so we can fix.
I think it's pretty awesome. There's a lot of tools out there that are using, I don't know what you call it, that are creating graphs of runtime, you know, and like that's all it's all well and good, except it's already running. So the time to release something that has a vulnerability to somebody knocking on that door is so minimal. That's not the time, right? You want to take the source code that you already have and be able to draw those connections, create those graphs, and detect the actual reality of your vulnerability and the reality of your risk as early as possible. And I think this is like a monumental leap forward what we're doing. It's very cool.
Well, also to the point of tying back to secrets earlier, you know, if you're getting a plan file, this is realistically already run through CI. If it's already run through CI, it's already in a Git commit. If it's already in a Git commit and there's a secret there, it's too late. Whereas going all the way through these variables and hopping through this, we can find those things potentially, you know, VS Code in local checkoff runs with maybe like a, you know, Git pre-commit hooks and things like that with checkoff, stuff that developers are already doing without that thing ever becoming, you know, a potentially dangerous commit. So yeah, very, very cool. And a reason why, you know, runtime and the plan file isn't kind of the be all and end all.
100%. Yeah.
All right. Awesome.
Awesome.
Cool.
Was that all of our demos? Is there what?
No,
one last one.
Like,
one last
do you know
one.
what?
Awesome.
Talking of kind of under promising and over delivering, I said Taylor had like 3 demos. But actually, like each one of the demos is 2 different features, so it's more like 6. So
multi-part.
You're welcome, everybody. But before we go on to the last one, yeah, for sure. Before we go on to the last one, I wanted to toot our own horn, Steve. You know, we're talking on this. We're talking on this show. We are also talking at an online conference, which is free for everyone to view. And we kind of have some exciting keynote, right? You're keynoting this wonderful thing.
Well, we're kind of hitting it from both sides, bookending it, let's call it. I've got a keynote along some speakers who I don't normally talk alongside. That's very cool. Talking about supply chain security, and then you're backing that up yourself with some solid advice, I believe, via a workshop.
I am indeed. Yeah, we have like a lunch and learn workshop where we're going to be kind of looking at, you know, practical examples of how you can quickly improve your supply chain security posture using some of the awesome tools like checkoff and kind of some of the stuff that Taylor's been working on. So yes, if you are free, definitely give the DevOps conference a check out, and we will see you there.
Yeah. Good operative use of the word free. The conference is free. Sign up. There are amazing speakers, not just us.
Free, like free beer.
Yeah. All right.
Yeah,
gratuitous self-plug aside.
It's usually really good fun. /tag end of plug. And yeah, demo 3. Taylor, you are going to close us out with, you know, probably the most complex one of the things we would love to have always been able to support in Terraform, right?
Yeah, absolutely. All right, so we've done the pretty complex stuff. We're taking that one step further. So if you're familiar with plan files, this is typically what people's end-all solution is to when you can't resolve something, just look at the plan file. You don't know manning or variables are in a weird place, then scan the plan file. It has everything. We've run into enough customers telling us that the plan file doesn't have all the information. A situation where the plan file there's no way from the information provided in the plan file to make the connection between resources. So this is the situation we got into, and we found the only solution was to combine the graph from the Terraform plan file and graph from our actual HCL scan, so the actual .tf files, and combine those two to get complete picture. So you may not have the picture because of inputs from the user or locals in the raw Terraform, which is where we prefer to scan things. And you may not have everything, you may not have the graph connection in the plan file. So how do you handle that situation? This is really kind of an edge case into enough customers, real world situations doing this, that we came up with a solution. So let me show what it looks like, and maybe it'll be a little more clear. So if I'm in, let's say in this Terraform plan, let me just make that a little bigger. And I've got, in this case, two S3 buckets. I've got AWS S3 bucket example, and then I've got another one here that's just AWS 3 bucket example 2. Well, we have a policy where we say you want to make sure you're blocking public access. And if you're familiar with Terraform, the AWS provider split that into multiple different resources. So it's now not just inside the AWS S3 bucket block that you define if there's public access. There's a separate source block that makes that definition. But what if that is the connection between that is housed in a local? So let's look for it. Okay, so I've got local bucket 2 and AWS S3 bucket access block, which is great. But how do I know where the connection is? There's no detail here that tells me where exactly, which of those two buckets is connected to this block saying block this public access, block public policy access. So there's no way in just the plan file to get the complete picture. But I do have that information in the actual source code. So if I look in here, I can see I've got a module. Okay, so now I need into here, see, okay, this is referring to a second module, really taking this up a notch. And that's where I finally get to the fact that I've got a local that makes the connection that gets me to public access policy is true. All right, so there's a lot there, but let's see what it looks like when I run a scan. So
that's like multiple levels of indirection through two different modules, each with their own VARs and things like that.
Yep, exactly. So if we were to scan just the plan file, we would have no idea that is the block public policy. And if we were to scan just the HCL, we'd have no idea that there's a connection between the two resources. So we have missing information, or we have incomplete information in both places. Now, what I'm doing here is I'm basically doing a normal plan file scan. So I've rendered out the plan file, and then I'm focusing on the framework of Terraform plan. I've got a single policy. We'll talk about that. And then the root plan for enrichment, this is originally what we developed this for, was if you have suppressions in the HCL that you want to carry over to the plan file, we make that connection. It has some other benefits now on top of that. And we've also got deep analysis here. So with that deep analysis flag, that's when we actually are merging the two graphs to make the complete picture. If I run that scan, you can see that both of these checks are passed because there are block public policy. They are there and they're working. If I were to just turn off that deep analysis, there'd be no way in the plan file to make that connection. And so we'd have basically a false positive here. It'd say, hey, you don't have public policy turned on. Block public policy, the public policy block turned on. And so we get these false positives unless, because of that local, because of that jump we have to make there, that's not even the plan file has the full picture. So this is why we've developed this deep analysis. So we highly recommend that this is reserved for when you have, there are performance implications of running this two graphs and then merging the two and combining the edges across. So it's really only if you have this use case where you're using locals or you have certain variable inputs and you want to have the complete picture. But in cases where we have a few enterprise customers that do this, it's very valuable for them to have this. They wouldn't get it from another solution.
That is awesome. So there's a possibility, hypothetically, that there are people watching that were getting false positives and maybe had suppressions in place because there was no way to get it correct. And now, with the addition of this feature, they can hopefully get insights that are accurate that they didn't get or couldn't get from anyone else.
That's right.
Cool.
Yeah.
What I'm hearing, Taylor, is that Chekhov is boldly scanning where no scanner has gone before. Would you say that's fair?
Ooh.
I would say that's a fair statement.
Well played.
Yeah. That is awesome. I feel like we need to just tweet out. In fact, I might after this show. Like, if you are using Chekhov or with Terraform, or you are using Terraform at all, like, this is the episode you need to watch back, because this solves so many conversations with like edge cases of the complexity of Terraform and HCL, which are needed to do useful things. But the number of times that we've had conversations with people that have needed these features, and boom, they're all here at the same time. This is super exciting.
The edge case pun is getting heavy.
Not intentionally.
I'm super excited. I think it was really great that we were given the leeway to invest real engineering resources on this, spend focused time, took some actual refactoring of our graph to get it right. And so there were a lot of performance and other improvements that came out of this that are kind of behind the scenes that you don't even see. And then you get all these other additional features that are coming out. So I'm super excited about them.
Did we end up moving to a new graph engine within Chekhov to support this, or is that
so
still TBD?
Not specifically to support this, but we did port over to iGraph. So we did move from Network X to iGraph, and this was for, among other things, performance. Just looking at the performance we could get the other graph DB that we found.
Awesome. Yeah. So cool. I guarantee the next conference we're at, where we're stood on a booth and people come over and go, "Hey, so I use Chekhov to scan my Terraform." Like, this episode answers like 90% of the queries that get asked. So yeah, super exciting. And thank you so much for joining us, Taylor.
Cool. Yeah. Thanks for having me.
No worries. Anytime. And do any of you gentlemen have any final thoughts? That sounded sinister. Any thoughts before we close out?
Forever.
Not at all. No, I think that was great. Just a reminder of the DevOps conference and casting way into the future. If you just want to hang, Matt and I will be at KubeCon in a month's time, almost exactly a month from today-ish. So I don't know if we're gonna do a live from KubeCon. The next episode, we'll have to wait and see. Subscribe to the channel, ring the bell, you'll find out.
Like and subscribe and ring, and yeah, we'll have some content from KubeCon. We promise that much. So wait and see. From Taylor, Steve, and myself, this has been episode 22 of Codified Security Office Hours. Thank you very much for watching.
Thanks so much.